Solving trinomials. So this is the extension of what we have just been doing when we were factoring. If you cannot do the previous couple chapters, you're going to have a lot of difficulty with this because this requires you to do that stuff first and then adds to it because you're going to be solving. Every single time we had in a question, we would have it and then we would factor it and turn it to something like that. Sometimes there's a little thing out in front like a 5x or something. And now what we're going to be doing is we're going to have that exact same thing, but we're also going to have an equal sign and a 0, and we're going to do a little bit more work. That equal sign drastically changes what the question is asking for. But before we can do solving, so finding out what, usually the letter is x, finding out the variable, finding out the x, finding out the unknown, before we do that for trinomials, we'll first look at some kind of like grade 7, 8, 9, 10 sort of solving questions that have come up in the past. So the whole idea is we want to get x alone, and you always want to get rid of any addition or subtraction before any multiplication or division. So we're going to add the 5 over. 2x is equal to 35 plus 5, which is 40. I kind of like to keep this little line here where the equal sign will always be. And then I can divide by 2, cross out that, so x is equal to 20. And you could check, you could put 20 back in here. 2 times 20 would be 40. 40 minus 5 is indeed 35. So x equals 20 is our answer. Then next one, so here's my equal sign. I will first get rid of any adding. So this 8 is being added to this negative 4x. We're adding this 8, so we'll subtract the 8. It's a positive 8 here, which is why we're subtracting it. So that's gone. I have a negative 4x equals 32 minus 8 is 24. Then I can get rid of this timesing by dividing by negative 4. Negative 4 over negative 4 will cancel out. So I have x equals 24 divided by negative 4, which is negative 6. So if you put negative 6 back into here, you would get negative 6 times negative 4, which would be negative 24, plus the 8 would be 32. So that's how you would know that it's correct. But these are what I'm looking for. X equals 20. X equals negative 6. Let's keep going here. We need to get rid of any adding first. We're adding this 15, so we'll subtract the 15. And we get x over 5 is equal to 10. 25 minus 15 is 10. And then times it by 5 on the numerator. That way the numerator and the denominator will cancel. And I get x is equal to 50. Again, you could check that. You could put 50 here. 50 divided by 5 is 10. 10 plus 15 is 25, which is what this is, 25. All right, keep going here. I'm going to, this is timesing by 2, so I'll divide by the 2. On the denominator there, we put the 2, so then we're left with an x plus 7 is equal to half of 84, so 42. And then we can get rid of this minus 7. So x is equal to, what is that, 35 plus 5? Yeah, x is equal to 35. And I think there's one more here. Oh yeah, where we now have x on both sides. So I'm going to just write 2x minus 15 is equal to, I have to bring this 5 in. So 5 times 3 is 15x minus 10 minus 8. I might as well put those together first. So I have a 2x minus 15 is equal to 15x minus 18. And so traditionally, I like to move over the smaller or more negative x. So the 2x here is smaller than 15. So I will subtract it over to this side. Negative 15 is equal to 15 minus 2 is 13x minus 18. Now I've written apparently quite aggressively because I've run out of room. So let's copy that over there, put my equal sign. So now I got to get the x alone. So I had x's on both sides. I had an x here and here, but I subtracted it over to make just a single 13x. So that's where I stand right now. Now I can get rid of my addition or subtraction first, so I'll add the 18. Negative 15 plus 18 is 3, is equal to 13x. And then divide by 13, divide by 13. So x is equal to 3 over 13, which I never would have guessed. You could try plugging 3 over 13 in those two x spots, but that would require a lot of work. So that's solving. I'll zoom out here. We will now start to solve. Oh no, actually I'm going to keep going here a little bit more because we're going to be solving with quadratics. Now this is still actually in my grade 9 course, so some of this stuff is still not new. We want to get the x squared alone. We want to get the x alone, so first we're going to get rid of this timesing by dividing. So you always want to get rid of any addition or subtraction, then you want to get rid of any multiplication or division, and then you want to get rid of any exponents. So there's no addition, subtraction, there's just multiplication, so we'll divide that over. So x squared is equal to 36 over 4, which is 9. And then to get rid of a squared, you could square root. Those cancel. So I get x is equal to the square root of 9, which is 3. Now that is kind of true. Now say I had x squared is equal to 9, and you're telling me, or I'm telling you, that if I put a 3 in here, I'll get 9. So 3 squared, yep, 3 squared is 9. But I'm also telling you, so if you put a 3 in here, you get 3 squared equals 9. Yeah, that works. I'm telling you too, if you put a negative 3. Negative 3 squared means negative 3 times negative 3, and negative 3 times a negative 3 is a positive 9. So negative 3 also works. So we learned this before, and we're just recapping. Whenever you square root to cancel out the square, whenever we're solving a question like that, we need to add a plus or minus. So x equals plus or minus 3. Before we go on to B, we'll take a look at C. So I need to get rid of any addition or subtraction first, so I'll minus the 12. So I get x squared over 5 is equal to 57 minus 12, which is 45, I think. And then I'm going to need to times by 5. Times by 5. So x squared is equal to 45 times 5. What? I'm going to have to do some work over here. 5 times 5 is 25. 5 times 4 is 20, plus 2 is 225. Okay. And then I need to get rid of, so first I got rid of the addition subtraction, then I got rid of the division here. So addition subtraction, so I got rid of the addition first, then I got rid of the division, and now I need to get rid of the exponent, so I'm going to square root. And that will cancel that. So I have x is equal to square root of 25, which is 15, but I'm going to have to add a plus or minus, because whenever I square root to cancel out a square in a solving question, we're going to need to do that. So let's take a look at this cube root question. So first there's a 6 that's being added, so it doesn't look like it's added, but it is being added, so I'll minus the 6 over. So I have a negative 4x cubed is equal to 32. And then I can divide by negative 4, divide by negative 4. So I get x cubed is equal to 32 divided by negative 4, which is 8, negative 8. And then in order to get rid of a cube, you can cube root. So cube cancels out a cube root, so you're just left with an x. And the cube root of 8, so we're trying to think of a number that multiplies by itself and then by itself again to get 8. So 2 times 2 times 2 is that number. 2 times 2 is 4 times 2 is 8. So you can't square root, a negative number, but you are allowed to cube root it, which is what we're doing. So the cube root of negative 8 is negative 2. So negative 2, and I'll just erase, I'll go right over here. This was the cube root equals negative 8. That's what this says. And so I'm saying, well, negative 2 is our answer. Negative 2 cubed equals negative 8. And is that true? Well, negative 2 times negative 2 times negative 2, does that equal negative 8? Negative 2 times negative 2 is positive 4. Positive 4 times the negative 2 is indeed negative 8. So the cube root of negative 8 is negative 2. So cube roots, and I'm not going to write this, but you can if you want. cube roots will not have a plus or minus. So that's one thing. Cube roots will not have a plus or minus, only square roots. And you can't have a negative for a square root, but you can for a cube root. So cube roots can have a negative on the inside. Square roots cannot. And let's take a look at the last question here. So I will get rid of this multiplication first, so I'll divide. So I have, I'll make a little sign again here, x4 minus 20 equals 54. Is that, no, 52. And then I will add 20 and add 20. So I get x to the 4 is equal to 72. And then I need to take a fourth root. So x is equal to the fourth root of 72. Now a fourth root is like a square root. It's an even power, so we will have a plus or minus. Don't forget that. And in case you've forgotten, I think in grade 10 we did this. This is 9 times 8, and then 9 times 8, and that's a 3 and a 3. That's a 2, 2, and a 2. And I can't do any groups of 4. So my answer just stays like this. Now, we did all this work, and this is review. All of this stuff is review. It has nothing really, I mean, these steps are involved, but it doesn't have anything to do with factoring. And so in the next video, we will do solving equations that will be trinomials, that'll be quadratics, but they're going to require factoring. None of these were requiring factoring, which is why they're all technically grade 8, 9, and 10 questions.